Prudent Scholars in association with Goa Headmasters Association.
Hello students, in our last class we learnt about acids, bases and salts, in which we learnt about different types of acids, that is organic acids that are obtained from the natural sources and inorganic acids that are obtained from mineral acids, and how these acids, bases play a very important role in our everyday life. Besides that, we have also learned if we want to identify any unknown solution as acids or bases, what do we have? We have something called as indicators, and these indicators are not only derived synthetically but they also occur naturally, and we have it in our house like turmeric, red cabbage, something that we use in our everyday life that helps us to distinguish between acids and bases. Besides this, we also learned about universal indicator, also called as pH, which means potence de hydrogen or power of hydrogen, and how it helps us to identify the strength of acid. When I talk about strength of acid, we speak about highly concentrated acids, okay, strong acids which have more number of hydrogen ions, less number of hydrogen ions, as well as strong base and weak bases. Besides this, we also learned how pH plays a very important role in our everyday life, from maintaining the pH value in our blood to maintaining the pH value of soil, and if there is slight change in pH, how it affects our health and also to that of others. For example, it will hinder the growth of plants if the soil pH changes. Now, how does the soil pH change? Because of formation of acid rain. So, these are the various concepts that we have covered in our last class. In today's class, we will be learning about the chemical properties of acids as well as bases. So, let us look at the first chemical property of acid, that is reaction of acid with metal. Okay, metal. Now, metals are of various types. Okay, depending upon the reactivity, we classify metals as highly reactive metals, moderately reactive metals and least reactive metals. Metals that we use as ornaments like gold, silver, platinum, these are called as the least reactive metals, and remember a very important point that these least reactive metals, they are not going to easily react with acids or bases, and that is why we use it in the form of jewelry or to make any other kind of article. Now, the metal that easily reacts with acid, they are highly reactive metals, especially those which belong to group 1 called as alkali metals, for example sodium, potassium, rubidium. Okay, these are highly reactive metals. So, over here you see students, we have given example. Metal, when it reacts with acid, it results in the formation of salt and hydrogen gas is being released in the reaction. So, you see over here zinc. Now, what is the source of metal we have taken? Zinc sulfate. Okay. Now, zinc, when it reacts with hydrochloric acid, it results in the formation of salt, that is zinc chloride, and hydrogen gas is being evolved in the reaction. Second example, sodium. Okay, sodium, when it reacts with sulfuric acid, it gives us sodium sulfate and hydrogen gas is released. Now, remember, hydrogen sulfate or sulfuric acid, it's a very reactive, it's a very strong acid. So, sodium, it combines with sulfate from hydrogen sulfate, that is sulfuric acid, and it results in the formation of salt of corresponding acid, that is sodium sulfate. Now, what is very important in this particular reaction is the evolution of hydrogen gas. Now, how do we come to know that hydrogen gas is being evolved in the reaction? So, let us look at how do acids and bases react with metal. So, over here you can see a test tube is taken, okay, and inside the test tube you can see there are pieces or zinc granules are being poured. Okay, you can see over here this grey colored, okay, zinc granules are kept, and to the zinc granules sulfuric acid is being added. On the addition of sulfuric acid, you can see there are gas bubbles which you can see very clearly. These gas bubbles, they escape from the delivery tube, okay, and over here you can see there is another beaker which consists of soap solution. Now, the moment hydrogen bubbles are evolved, if you take a matchstick and you light it, okay, you will hear a popping sound. indicating that hydrogen gas is released in the reaction. So this is the reaction which is shown between the zinc granules and dilute sulfuric acid in order to test for evolution of hydrogen gas. Next we are having reaction of acids with metal carbonates. Now in your 9th standard you have learned about various ionic salts, okay. Metal carbonates, metal bicarbonates, phosphates, sulfates, okay. Now here we are talking about metal. Any metal when it combines with a carbonate, we get it metal carbonate. For example, sodium carbonate, Na2CO3, zinc carbonate, magnesium carbonate, etc. So when metal carbonates react with acid, it results in the formation of salt, and carbon dioxide and water is given out. Now remember, a very clear distinction is there in when the metal reacts with acid, which gas is released? Hydrogen gas is released in the equation. Okay, but over here in case of metal carbonates, when metal carbonates react with acid, it's carbon dioxide gas that is evolved in the reaction. So you see over here sodium carbonate, when it reacts with hydrochloric acid, it results in the formation of salt sodium chloride, carbon dioxide and water. You can see the physical state of each is being mentioned in the equation. This carbon dioxide gas which is released, now how do we come to know whether carbon dioxide gas is being released? In order to test for carbon dioxide, there is a test called as lime water test. Now when I say lime water, I do not mean nimbu pani, okay. Lime water means calcium hydroxide, also called as slaked lime, okay. So over here you can see, students, when carbon dioxide gas is being passed through slaked lime, okay, or lime water, it will result in the formation of precipitate, and that precipitate is nothing but calcium carbonate. So the milky solution that you get on passing carbon dioxide is resulting because of formation of calcium carbonate, okay. So let us have a look at the experiment. Now we know that when sodium carbonate or sodium bicarbonate, when it reacts with acid, it releases carbon dioxide gas. Now how do we test the carbon dioxide gas? In order to test, we do a test called as lime water test, okay, that is slaked lime calcium hydroxide solution. I will take some amount of calcium hydroxide solution into my test tube. This is a pipette. I will try to blow, okay, I will try to blow the air, and you will realize that the clear solution in the test tube will turn into milky. So what I am doing, I am exhaling carbon dioxide. So now you see the solution has turned milky in color, indicating that there is formation of calcium carbonate. If excess of carbon dioxide is passed through the lime water, then calcium carbonate will turn into a soluble form called as calcium hydrogen carbonate or calcium bicarbonate. So this is the lime water test in order to detect the presence of carbon dioxide gas that is released when metal carbonates or bicarbonates react with acid. Okay, so let us take another example, okay, that is calcium carbonate. Calcium carbonate, when it reacts with sulfuric acid, it results in the formation of calcium sulfate. So what is happening, students, over here? Calcium is combining with sulfate, okay, it is a type of double displacement reaction and results in the formation of calcium sulfate, giving us carbon dioxide and water. The next example we are having over here, see over here we have taken hydrogen chloride as an acid. In the third example, we have taken nitric acid. So when sodium carbonate reacts with nitric acid, it results in the formation of sodium nitrate. So what the reactive metal does? The reactive metal, it displaces hydrogen from its solution, okay, resulting in the formation of sodium nitrate, water and carbon dioxide. So you see over here we have taken three different types of metal carbonates: sodium carbonate, calcium carbonate, and again we have taken sodium carbonate. Reacting with different types of acid, it results in the formation of same products, that is salt, water and carbon dioxide gas is being given out in the reaction. So you can see this particular test is to test the whether carbon dioxide gas is actually released in the reaction. So you can take a test tube, okay, containing sodium carbonate. To that what is being added? Hydrochloric acid is being added. Immediately on addition of hydrochloric acid, it will result in the formation of carbon dioxide gas, which is being connected to the delivery tube to other test tube containing calcium hydroxide, that is lime water. On bubbling this solution, on bubbling calcium hydroxide with carbon dioxide gas, what happens? It results in the formation of precipitate, that is calcium carbonate. Okay. Now same thing happens in case of reaction of acid with hydrogen carbonates, also called as bicarbonates. Hydrogen carbonate is HCO3 minus. Okay. So we see carbonate is CO3 minus 2. Okay, these are called as carbonates, and hydrogen carbonate also called as bicarbonate. Okay, the group is HCO3 minus 1. Fine. So over here what is happening, if any metal, any reactive metal combines with hydrogen carbonate, let us take example of sodium. Okay, sodium hydrogen carbonate can be written as NaHCO3 minus 1. Even if you don't write minus 1, it is being assumed that it is minus 1. So this is an example of sodium hydrogen carbonate or also sodium bicarbonate. Even we can take magnesium. Magnesium, when it combines with HCO3, what we are getting? Magnesium carbonate. Okay, so this is examples of various metal carbonates. Over here we have taken sodium bicarbonate. When it reacts with sulfuric acid, it results in the formation of salt, that is sodium chloride, evolving carbon dioxide and water. So in the two chemical reactions you have seen what is common is the product. When metal carbonates or metal bicarbonates, when they react with acid, it results in the formation of salt, water, and carbon dioxide gas is evolved in the reaction. So carbon dioxide turns lime water milky when passed through it. This happens because of the formation of white precipitate called as calcium carbonate. But if you pass excess of carbon dioxide through the solution, what will happen? The calcium carbonate that is being formed, which is milky, okay, it will turn into, see, calcium carbonate is insoluble in water, okay, but on addition, on passing excess of carbon dioxide, you are going to get a clear solution which indicates that it has resulted in the formation of calcium hydrogen carbonate. Okay. So calcium hydroxide plus CO2 gives you milky or precipitate resulting in the formation of CaCO3, but on passing excess carbon dioxide through the solution, calcium carbonate, it will disappear because it has formed calcium hydrogen carbonate, which is soluble in water. Okay. The third reaction that we have is reaction of acid with metal oxides. You have learnt in your previous class about metal oxides and non-metallic oxide. Examples of metallic oxides are sodium oxide, magnesium oxide, calcium oxide, zinc oxide. So if you take this metal oxide and you try to test its acidic or basic nature with the help of litmus paper, you will realize that all metallic oxides, okay, they turn the red litmus into blue. So whenever litmus paper, okay, so we are having metallic oxides like magnesium oxide, calcium oxide, sodium oxide. Okay, if either of these metal oxides, few examples of it, if either of these metal oxides are being tested, okay, with the help of litmus paper, what will it result? Okay, the red litmus paper will change into blue, indicating that metallic oxides are basic in nature. Very important thing that you have to remember, students. all metallic oxides, they are basic in nature. So over here you see, if you are reacting a metallic oxide whose nature is basic with an acid, what will it result? Basic, a base and acid, when it reacts with each other, it results in the formation of a neutral compound, which is nothing but your salt. Okay, so when metallic oxide reacts with acid, it results in the formation of salt, which is neutral in nature, and formation of water. Okay, so here is an example. Hydrochloric acid reacts with calcium oxide, resulting in the formation of salt, that is calcium chloride, and water. Okay, another example, sulfuric acid reacts with zinc oxide, giving you zinc chloride and water. So calcium chloride and zinc chloride that you have got is your salt. Okay. So this is what we have learned about chemical properties of acids. So acids react with metals to give you salt and hydrogen gases evolved in the reaction. Acids react with metal carbonates and metal bicarbonates, giving you salt, water and carbon dioxide gas is released in the equation, which is tested using lime water test. Then we have learned how metallic oxides react with acid, giving you salt and water. Okay. Next we will move on to chemical properties of bases. Bases, those bases which are water soluble are called as alkalis, hence I have written alkali over here. Alkali reacts with metal to give you salt and hydrogen gas is being released in the equation. So you see, there is the properties of acids and bases are similar, but just that they are opposite. Okay, what is happening over here? You are taking the base sodium hydroxide and you are reacting it with metal. What are you getting? You are again getting a salt, which is sodium zincate, and hydrogen gas is evolved in the reaction. Now how will you test for hydrogen gas? Same as you have done earlier. You take a matchstick and you lit it and it will burn with a popping sound. Next example we have taken over here is you have taken another metal, that is aluminium. Aluminium is a moderately reactive metal. It reacts with sodium hydroxide, resulting in the formation of sodium aluminate, which is a salt, and hydrogen gas is being evolved in the reaction. Next we have reaction of bases with oxides of non-metals. Okay. So far we have seen about metallic oxide and its nature. Now let us look at the nature of non-metallic oxides. Okay, examples of non-metallic oxide: sulfur dioxide, carbon dioxide. Okay, these are the gases which are even present in the atmosphere. Now, if you do the test to indicate the nature of this oxide with the help of litmus paper, okay, you will realize that the red litmus paper does not change its color, no change. Okay, but when you take a blue litmus paper, it turns into red color. So you know litmus paper, when it remains unchanged. So red litmus paper remains unchanged because it's showing that non-metallic oxides nature is acidic, and blue litmus paper changes into red color, indicating that non-metallic oxides are acidic in nature. So remember this point also, which results in the formation of acid rain. So these non-metallic oxides, they are present in the air, okay, and when they mix with rainwater, it changes the pH of rainwater. So remember students, since non-metallic oxides are acidic in nature, when they react with base, what are they going to do? They are going to neutralize, okay, and it is going to result in the formation of salt and water. So when you test this solution, you will realize that there is no change in the litmus paper, indicating that the solution is neutral. Okay, this is another example of neutralization reaction also. So a base, sodium hydroxide, when it reacts with carbon dioxide, it results in the formation of salt, which is called as sodium carbonate, plus water is given in the reaction. Calcium hydroxide, okay, which is a non-metallic oxide, reacts with carbon dioxide, formation of calcium carbonate and water. Fine. So when A non-metallic oxide reacts with a base, you are getting salt and water. So, I have been talking about neutralization reaction. Okay, so what exactly is neutralization reaction? We know that acids, okay, what they have in common, they are having H plus ions. Okay, while bases, they are having OH minus ions. Now when H plus ions combine with OH minus ions, what will it result in the formation of water? So what is happening over here? Hydrogen ion, okay, and hydroxide ion. This comes from acid and this is coming from base. Okay, so they are neutralizing the effect and resulting in the formation of water. So here the example that is given, okay, on the slide, hydrochloric acid. So hydrochloric acid is a source of your H plus ion, base sodium hydroxide. So OH minus ion source is your base sodium hydroxide. When they react with each other, there is exchange of ions that take place. Remember students, these are ionic equations. So when there is exchange of ions taking place, it is resulting in the formation of salt and water. So let us see how exactly this exchange of ions take place. So when I am writing, I will write it in a simpler form, HCl. HCl is having H plus ion and Cl minus ion. NaOH is having Na plus ion and OH minus ion. Now when you mix them together, what is happening? Now, sodium ion will get exchanged with Cl minus ion, resulting in the formation of your salt, NaCl. Okay, and what remains? H plus and OH minus ion, which combines to give you water. Therefore, this reaction is your neutralization reaction. Okay, I hope this is clear to all of you all. So in the second example, you see just that your base that you have taken over here is calcium hydroxide. When calcium hydroxide is reacting with hydrochloric acid, it is resulting in the formation of calcium chloride and water. Fine? So let us see how neutralization reaction is carried out. Beaker labeled A consists of dilute hydrochloric acid. I will add some amount of acid into the conical flask. Okay, and then this is phenolphthalein indicator. We'll add few drops of phenolphthalein indicator. On adding phenolphthalein indicator, you see that there is no change in color. Now, let us add base, that is dilute sodium hydroxide. So I will add some amount of sodium hydroxide into the beaker. On adding sodium hydroxide, you will realize that there is a color change that starts taking place. Okay, so you will see slight tinge of pink color appearing. So we know phenolphthalein indicator, it changes to pink color in the presence of base. Okay. So we'll keep adding it till we get a pinkish color. So you see the pink color is disappearing, showing that the base is trying to neutralize the acid. Okay, you can see it very clearly. Now the solution has turned into dark pink color, showing that this solution is now basic in nature. Now if I add few more drops of acid, you will realize that the pink color will start disappearing. Okay, so here what we have learned students, that the base has nullified the effect of acid. So the H plus ions from acid and OH minus from the base have combined to give you a neutral solution, that is water. So this was about neutralization reaction. So here we have learnt about chemical properties of acids and chemical properties of base. Now let us move to a complete new part of the lesson, that is salt. Okay, we know we use salt in our everyday life, the table salt, a common salt, okay, without which the taste of all the food items is incomplete. So what exactly are, from the chemistry point of view, what exactly are salts? Salts are ionic compounds. Okay, just now we have seen over here, ionic compounds are those which are having cations and anions, that is positive ions and negative ions. So salts are ionic compounds which are produced after the neutralization reaction between acid and base. Okay, so when I am saying ionic compounds, ionic compounds are usually formed between a metal and a non-metal. Okay, for example, if I am taking sodium as a metal and my non-metal is chloride ion, okay, they are going to combine and what I am going to get is NaCl, okay, which is having Na plus and Cl minus ions. So these are ionic compounds which are usually formed between a metal and a non-metal. Similarly, if I take another example, instead of taking sodium, see I write magnesium, and my non-metal is, instead of chlorine, say I take bromine. Okay, bromine is written as Br2. Okay, when they combine, what is the salt that I will get? I am going to get magnesium bromide. Okay, MgBr is going to be my salt. So ionic compounds are produced. Now how are they produced? We just learnt in the previous equation that ionic compounds are produced by the neutralization reaction between acid and a base. Now salts are electrically neutral. So overall charge on the salt is 0. Okay, they are electrically neutral compounds and there are number of salts, but the most common one that we use in our day-to-day life is sodium chloride, NaCl, and is one of the most common and one of the most important compound that we will be learning about which in detail. Now what are the characteristics of salt? Most of the salts are crystalline solid. Okay, now what do you mean by crystalline solid? If I am giving you sodium chloride and I am giving you talcum powder, okay, and I tell you to dissolve both of them in water, the one which is crystalline will dissolve in water, but talcum powder will not dissolve in water, hence we will call it as amorphous. Okay, so salts, most of the salts are crystalline solid and they may be transparent or opaque. Most of the salts are soluble in water, that means they dissolve in water, and solution of the salt conducts electricity in their molten state also. A very important point that you have to remember, that salts conduct electricity only in its molten state or in its aqueous state. Now what is the reason behind it? We have learnt when we were learning that about conduction of electricity by acids and bases, one of the main criteria for conduction of electricity is movement of ions. Okay, so salts conduct electricity. Okay, they will conduct electricity either in the molten state or in its aqueous state. Okay, why it is going to conduct electricity? I am having sodium chloride NaCl. When I dissolve it in water, it is going to give me ions Na plus Cl minus ions. So when you dissolve sodium chloride in water, there is free movement of these ions. The free movement of ions helps in the conduction of electricity. But if the same salt is in its solid form, it is not going to conduct electricity because of its rigid structure. So solution of the salts conduct electricity in their molten state also. The salt may be salty, sour, sweet, bitter and umami, that is savory. Neutral salts are odorless. Odorless means they do not have any peculiar smell. So if I give you salt and I tell you smell it, you are not going to get any peculiar smell. Salts can be colorless or colored. So you have sodium chloride is a salt which is white in color, which you all have seen. Okay. Then we have another salt called as pink salt or Himalayan salt, which is pink in color. It has a slight pinkish color. Then we have copper sulfate, okay, which is bluish in color, bright blue in color. So salt, it need not be that salt needs to be only colorless, but salts occur in various colors. Now let us learn about the family of salts. Okay, we are having over here chloride family, calcium family and zinc family. Now sodium chloride and calcium chloride, they belong to the chloride family. Calcium chloride and calcium sulfate belongs to calcium family. Zinc chloride and zinc sulfate belongs to the zinc family. So these are various family of salt. This is just for your brief information. Okay, so you can see over here different colors of salt. Okay, from left to right, if we see, we are having different salt. Blue color, this one is your copper sulfate. Okay, this one is your calcium nitrate. So you can see salts are of different color and they are belonging to different family. So we are having different types of salt: neutral salts, acidic salts and basic salts. Now let us first look what exactly are neutral salts. Neutral salts are produced because of reaction between strong acid and strong base. So what is the main criteria for formation of neutral salt is that you require a very strong acid like hydrochloric acid, sulfuric acid. These are strong acids, and strong base. Okay, so when the salt is formed, when the reaction between strong acid and a strong base, it results, the nature of the salt is going to be neutral. Now when do we say salts are neutral? When we know the pH value will be equal to 7. So when pH value is equal to 7, the type of salt that you get is a neutral salt. So let us look at the example. Here is the reaction between sodium hydroxide and hydrochloric acid, giving you sodium chloride and water. So sodium chloride is your table salt that you use. Okay. Another example we have is reaction of sodium hydroxide with sulfuric acid. Okay. If I ask you about the type of reaction that you have learnt in chemical reaction and equation, you will realize this is a double displacement reaction. Okay, so students, you can relate your knowledge of chemical reaction and equation even in this lesson. So sodium hydroxide reacts with sulfuric acid, giving you sodium sulfate and water. Let us take some other example. Okay, suppose I am taking potassium hydroxide, KOH, and I react with a very strong acid, that is H2SO4. Okay, both of them in their aqueous state. Now we know I am going to show you the ions which are present. In potassium hydroxide, we are having K plus OH minus and H plus and SO4 minus 2. So when these react, what there will be exchange of ions. Since it is a double displacement reaction, what we are going to get is we are going to get potassium sulfate K2SO4, which is going to be your salt, and H2O. Okay, so 2KOH plus H2SO4 gives us K2SO4 plus H2O. So here you are having a strong base potassium hydroxide, a strong acid that is sulfuric acid, giving you salt, potassium sulfate and water. So the type of salt that you have, its pH is equal to 7, hence it is neutral in nature. So here there is a third example, but the acid chosen is different. The acid taken is hydrochloric acid. When hydrochloric acid reacts with potassium hydroxide, okay, what you are getting? Potassium is going to displace hydrogen from its place and you are getting potassium chloride and water. So these are the examples of neutral salt: NaCl, KCl, Na2SO4, anything that is formed between a strong acid and a strong base. Next type of salt that we have is acidic salt. Now you know, when I am talking about acid, that means the pH value is going to be less than 7. Now how are these salts formed? How are acidic salts formed? They are formed when there is a reaction between a strong acid and a weak base. Okay. So the pH value of acidic salt is lower than 7. For example, ammonium sulfate, ammonium chloride, these salts are acidic in nature. So you can see over here, students, first example we are having is ammonium hydroxide. Ammonium hydroxide, when it reacts with hydrochloric acid, the salt that will be formed is ammonium chloride, because ammonia is going to displace hydrogen from its solution and is going to combine with chloride, forming ammonium chloride and water. Similarly, ammonium hydroxide, when it reacts with sulfuric acid, see in both the cases, hydrochloric acid and sulfuric acid are strong acids and ammonium hydroxide is a weak base. When do we say a base is a weak base? When it partially dissociates, giving you hydroxide ions. It's giving you ammonium chloride and water and ammonium sulfate and water. So, the pH of these salts is going to be less than 7. Next type what we have is called as basic salts. That means the pH of this salt is going to be more than 7 and they result when there is a reaction between a weak acid and a strong base. Okay, for example, carbonic acid, okay, which is a weak acid, when it or even acetic acid. So, you can see two examples given over here. Carbonic acid and acetic acid both are weak acid, but they are reacting with a strong base. When they react with a strong base, it results in the formation of corresponding products, that is sodium carbonate and water, and over here sodium acetate and water. So, what is the reason? What is the reason behind the formation of acidic, basic and neutral salt? Okay, when a strong acid reacts with a weak base, the base is unable to fully neutralize the acid because the acid is very strong but the base is weak. That means the number of hydroxide ions in the solutions are less. So, if I am having a beaker, okay, I am having strong acid, the number of H plus ions in my beaker are more. Okay, theoretically, the number of H plus ions in my beaker are more and the number of OH minus ions are less. Since the number of OH minus ions are less, okay, what will happen? The base, it will not be able to neutralize all the H plus ions that are present. Hence, due to this, our acidic salt will be formed because the number of H plus ion will still remain in beaker which are not being neutralized by the base. In the second case, so this was your first case. Now, in the second case, when a strong base reacts with a weak acid, the acid is unable to fully neutralize the base. Now, over here what you are having in the second case, the number of OH minus ions in your beaker are more because you are using a strong base. They have completely dissociated to give you hydroxide ion. But the number of H plus ions are less. Now, since the number of H plus ions are less, they will not be able to completely neutralize the OH minus ions, resulting in the formation of basic salt. Okay. And in the third case, now what I am having, this was my second case. In the third case, I am having equal number of OH minus ions and H plus ions. I am having 2 H plus ions and I am having 2 OH minus ions. So, when equally strong acid and base react, they will fully neutralize each other. And when they fully neutralize each other, what I am going to get is my neutral salt. So, over here in first case, that is when the number of OH minus ions are less, the pH value will be less than 7, indicating that it is a acidic salt. In the second case, the pH value will be more than 7, indicating that it is a basic salt. But in the third case, the pH value will be equal to 7, indicating that it is a neutral salt. Okay. How we will come to know the pH value? We had learnt in our last class by looking at the pH paper, that is our universal indicator. So, the neutral salt, okay, it is going to have pH value 7, acidic will range from 0 to 6 or 6.5 and so on, and basic is going to be more than 7. Now, let us move on to the most important part of our lesson, that is what are the important compounds that can be prepared from the salt. Okay? Now, the first one that we have is common salt called as sodium chloride. How it is formed? When there is a reaction between a strong acid and a strong base. So, reaction between sodium hydroxide and hydrochloric acid, it is a neutral salt. Now, the pH value of sodium chloride is about 7, and sodium chloride is used, you know, it is used, if there is no salt in your food, you will not be able to eat it because it is one of the main ingredient that requires to enhance the taste of your food. Okay? But besides being used in food, it is also finds a very wide variety of application, like manufacturing of many chemicals. Okay, and imagine you are manufacturing chemicals from salt. So how exactly it is being done? Let us have a look at that. So some important chemicals from sodium chloride. The first one that we will be learning is sodium hydroxide. The common name of sodium hydroxide is caustic soda. Okay, so you can see over here it is being written sodium hydroxide is a strong base, and it is also known as caustic soda. And how it is being obtained? It is being obtained by the electrolytic decomposition of solution of sodium chloride. Now what exactly is brine? I have written brine over here. Now what exactly is brine? A very saturated solution of sodium chloride. That means if the amount of concentration of salt is very high, okay, we call that solution as brine. So in the process of electrolytic decomposition of brine, that is aqueous solution of sodium chloride, brine decomposes to form sodium hydroxide. We will have a look at the experiment in our next slide. Now in this process we are obtaining byproducts. Okay. From this we are obtaining hydrogen gas and also chlorine. Chlorine is released at the anode and hydrogen gas is obtained at the cathode. Anode is a positively charged electrode, whereas cathode is a negatively charged electrode. Now this whole process is known as chlor-alkali process. Now why it is called as chlor-alkali? Chlor is the word which is derived from chlorine. Since we are getting chlorine, we are using chloro. Okay. Okay, so chloro, so we are using chlor, and sodium hydroxide, okay, we know since in its aqueous state it's a soluble base, we call it as alkali. So combining the two letters we are getting chlor alkali. Okay, so the process is called as the chlor alkali process. So you can see over here, these are the important products that are formed. So you are taking common salt. On electrolytic decomposition of common salt, okay, hydrogen gas is evolved at cathode, that is a negative electrode, and chlorine gas is released at anode. And over here your main product is sodium hydroxide, but let me tell you, none of the things are getting wasted. All the byproducts on electrolytic decomposition of sodium chloride, okay, everything that you obtain over here is being utilized. You can see over here hydrogen is used in the manufacture, hydrogen fuels, then margarine, okay, which is a kind of butter, okay, then ammonia for fertilizers. You know, in Haber-Bosch process we require hydrogen. Then in case of anode, it is chlorine gas is being released, which is used for water treatment, swimming pool, PVC, disinfectants and so on. And sodium hydroxide used, very important, it is used in soaps, detergents, artificial fibers and so on. Okay. So these are some of the important products formed during the chlor-alkali process. Now use of different products, I have already discussed this with you. Okay, how hydrogen is being used, chlorine gas and sodium hydroxide is being used for various purposes. Okay, so chlorine used as disinfectant in swimming pools. Okay, then hydrogen gas which is being released, it is being used in the manufacture of fertilizers in Haber-Bosch process, then manufacture of plastic, that is polyvinyl chloride. So these are some of the wide varieties that we we can find wide applications in our day-to-day life. Now let us move on to the next one, that is bleaching powder. Okay, bleaching powder, the chemical formula is CaOCl2, also pronounced as calcium oxychloride. Bleaching powder is also known as chloride of lime. Okay, it is you must have seen, all of you all must have seen bleaching powder. It is solid first of all, and it is yellowish white in color. It can be easily identified by the strong smell of chlorine. So you see, whenever the bleaching powder, the smell spreads everywhere. Because what is the reason behind a very strong smell of bleaching powder? It is because it is a smell of chlorine. Now when calcium hydroxide, that is slake lime, it reacts with chlorine, it is giving us calcium oxychloride and water is being formed. So you are reacting a base, that is slake lime, with chlorine, okay, resulting in the formation of the bleaching powder, calcium oxychloride, and water is released as a byproduct. Now what is the nature of bleaching powder? It is basic in nature. Okay, and the term bleach, it means removal of color. You must have heard, bleaching of clothes. If you want to remove any particular, even you get something called as vanish, you put it, mix it with water, you dip your clothes. If there is any stain on your clothes, it's going to go out very easily, because it is, the term bleach itself means removal of color, and bleaching powder is often used as a bleaching agent. Now, why does it work so effectively? It works effectively because of oxidation. Okay, what is oxidation? Addition of oxygen. So, if you see over here in bleaching powder, you are having O, calcium oxychloride. Okay, and it is working as an excellent bleaching agent because it undergoes oxidation, and chlorine in the bleaching powder is responsible for bleaching effect. Okay. So, what is the use of bleaching powder? It is widely used as disinfectant to clean water, okay, moss remover, weed killer. So, nowadays it is rainy season, and you must have seen, if your veranda or near the ferry boat, that place which is there, where there is all moss formation that takes place. So, what they do, they add powder, okay, they add bleaching powder, and that is going to help removal of the moss, so that, to prevent any mishap. So, bleaching powder is used as an disinfectant to clean water, moss remover, weed killers, etc. Weeds are the unwanted plants, so even it is being used by the farmers. It is also used for bleaching of cotton in textile industry. Let me tell you, it finds a very wide use in the textile industry. Okay, bleaching of wood pulp in paper industry. So, when paper is being manufactured, it is not bright white in color, it is yellowish in color. Paper is obtained from plants. Now, if your notebook, the pages of your notebook, if they are very white in color, it is because it has undergone the process of bleaching. So, bleaching powder is used for bleaching of cotton in textile industry, and it also finds a very important role in the paper industry. It is used as oxidizing agent in many industry, same in paper. And so, you can see this is the color of paper when it is being synthesized. It is not bright white, it is yellowish in color. So, here is one of the industry that makes wide use of bleaching powder. Now, before we move on to the next chemical that is being prepared, now remember students, yes, we are using bleaching powder effectively, but a question to you is, would you recommend anyone using this? Because when you are using, we have to be very innovative. We have to see for something that is less harmful to the nature. We know bleaching powder is basic in nature. So, immediately when you are using, when the farmers are using it in their field to kill the weeds, that means we are again changing the pH of the soil. When we are using it, to remove the moss or algae formation that has taken place, when we are washing it, it goes into the water body. So, we have to be a bit careful when we are using bleaching powder. Also, the smell is very strong, so care has to be taken, because if it directly comes in contact with your hands, it will cause a burning sensation, and also it is going to cause irritation to your eyes. So far we have learnt two compounds that are prepared from sodium chloride, caustic soda, that is sodium hydroxide, and we have learnt about bleaching powder. So now let us move on to the next. I know it's rainy season and everyone so desires to have these pakoras and crispy pakoras at home. So what is the main ingredient that makes this pakora so crispy and so light? It is nothing but your baking soda. So what is baking soda? You are so surprised. Yes, baking soda is, we have learned in our last session that it is a type, it's a mild base, very mild base, but it is a very important product which is obtained from chloralkali process. So baking soda is obtained from chloralkali process, and the chemical name is sodium hydrogen carbonate or sodium bicarbonate. So it is also, it's having various names: bread soda, cooking soda, bicarbonate of soda, sodium bicarb, bicarbo soda, or simply bicarbonate, etc. are some of the names of baking soda. It's not only added in pakoda, it's also added in dosas. So you see how widely we are using these products in our house. Now, how exactly it is being prepared? It is being prepared by a method called as solvase process. Okay. Now, what is being done in this? First of all, baking soda is obtained by reaction of brine. I told you brine is a very strong solution of very strong salt solution, And when, so students please, this is B-R-I-N-E, not brain, brine it is. So sodium chloride when it reacts with, okay, when sodium chloride solution or brine, okay, when it reacts with carbon dioxide in the presence of ammonia, what you are getting is ammonium chloride and sodium bicarbonate, okay, and this process is called as Solvay's process. So in this process what is happening, calcium carbonate is used as the source of carbon dioxide, okay. Now how calcium carbonate is used as the source of carbon dioxide, let us see. So calcium carbonate, that is CaCO3, when you heat it, okay, it is going to undergo decomposition reaction giving you calcium oxide plus carbon dioxide. So carbon dioxide that is being released, it is being used in this process, that is Solvay's process. So and the resultant calcium oxide, so this calcium oxide that is being obtained, it is used to recover ammonia. Okay, it is used to recover ammonia from what? From NH4Cl, that is ammonium chloride. I repeat again. Okay, baking soda is obtained by reaction of brine with carbon dioxide and ammonia. So from where are you getting carbon dioxide and ammonia? Calcium carbonate undergoes decomposition to give you calcium oxide and carbon dioxide. Carbon dioxide which is released is being used in the process. Calcium oxide is used to recover ammonia from ammonium chloride. Okay. So this is how baking soda, that is sodium hydrogen carbonate or sodium bicarbonate, is being prepared using the method called as Solvay's process. Now let us see some properties of sodium bicarbonate. First of all, it is a crystalline solid and it appears as fine powder. Okay, it is amphoteric in nature. We have learned about acidic nature, we have learned about basic nature. Now what is amphoteric nature? When a substance can react with both acid as well as base to give you salt and water, we call that nature as amphoteric. Okay. It is sparingly soluble in water. What do you mean by sparingly soluble? That means it is not going to dissolve completely in water. Some amount of salt will still remain. Okay. Now when baking soda is heated, it decomposes to give you sodium carbonate, carbon dioxide in water. Okay. NaHCO3. That means when you take baking soda and you supply heat to it, it is going to give you sodium carbonate after decomposition. Now what is sodium carbonate? Sodium carbonate is washing soda. Okay. So sodium carbonate is formed after thermal decomposition of sodium hydrogen carbonate, decomposes into sodium oxide and carbon dioxide. So when you further heat sodium carbonate, it is giving you sodium oxide and carbon dioxide. So what has happened in this particular reaction? There is loss of water molecule. Since there is loss of water molecule, this particular reaction is known as dehydration reaction. Okay. So these are some of the properties of sodium bicarbonate. So now let us next look at use of baking soda. So we have already know baking soda is used in making baking powder. Students, there is a difference between baking soda and baking powder, which we will study soon. Now baking powder is used in cooking as it produces carbon dioxide, which makes the batter soft and spongy. Baking soda is used as an antacid. It is also used in toothpaste, which makes the teeth white and plaque free. Baking soda is used in cleansing of ornaments made of silver. It is also, since sodium hydrogen carbonate or baking soda, it gives carbon dioxide and sodium oxide on strong heating. It is also used as fire extinguisher. So some of the main important uses of baking soda is used in the preparation of baking powder. It is being used as an antacid. It is being used as fire extinguisher. Okay, and also it finds a very good use in toothpaste because baking soda is basic in nature. Okay. I am sure you must be tempted right now looking at this picture. So this is your onion fritters and this is the cake in which baking soda is being used. Now how exactly is baking soda different from baking powder? First of all, baking powder is produced produces carbon dioxide in heating, so it is used in cake to make the batter spongy. So exactly what happens when you are adding baking powder in the dough or in the mixture, carbon dioxide gets trapped in the dough. Now when you start heating it, the trapped carbon dioxide from the dough, it tries to escape out, leaving those spongy bubble like structure. Okay, so baking soda, when you heat it, it is giving you sodium carbonate, carbon dioxide and water. But it is not used in cooking because on heating, baking soda produces sodium carbonate along with carbon dioxide, and since there is production of sodium carbonate over here, it is going to give a bitter taste, okay, in cooking. So baking powder, now in order to neutralize this bitter taste, what is being done? It is being mixed with a mild edible acid, okay, and the mild edible acid that is being used is tartaric acid. You know the natural source of tartaric acid, it is also found in tamarind, okay. So baking powder is a mixture of baking soda and mild edible acid, and tartaric acid is mixed with baking soda to make baking powder. Okay, but if you just heat it and if you are getting sodium carbonate, then this is going to give bitter taste to the food. So baking soda, when it is being mixed with a mild acid, that is tartaric acid, okay, tartaric acid is an organic acid that is being obtained, you know, the natural source of tartaric acid is tamarind. So tartaric acid, when it is mixed, it is releasing carbon dioxide, water, and what we are getting is sodium tartarate. So what is the basic difference between baking soda and baking powder? Baking soda is sodium hydrogen carbonate or sodium bicarbonate, whereas baking soda is sodium carbonate mixed with a mild acid. Okay, now why mild acid needs to be mixed? Otherwise the food will taste bitter. Fine, so when baking powder is heated, we are getting sodium hydrogen carbonate, decomposes to give us carbon dioxide and sodium carbonate, and it is carbon dioxide which causes the bread to or cake to become fluffy. Whereas the role of tartaric acid is to remove the bitter taste due to the formation of sodium carbonate. The next important compound, okay, that is finds a very wide applications for domestic purpose, that is cleaning laundry and all, that is washing soda, also called as sodium carbonate. Now the process you see is the same Solvay's process. Over here what is being done, sodium carbonate is manufactured by thermal decomposition of sodium hydrogen carbonate. So when you heat baking soda, as you saw in the previous slide, your product will be sodium carbonate and water. So sodium chloride, carbon dioxide, ammonia, water, okay. What are you getting? Ammonium chloride, this is the electrolytic decomposition reaction that is from which you have obtained these various byproducts which is being used over here, okay. You are getting sodium bicarbonate. This sodium bicarbonate, this is your main reaction that you need to know. This sodium bicarbonate on heating is giving you sodium carbonate. Okay, now what is written is anhydrous. You are getting anhydrous sodium carbonate. Anhydrous means there is no water molecule in it. Okay, so but when you take anhydrous, okay, this is your anhydrous without any water of crystallization. When you take anhydrous sodium carbonate and you mix it with water, okay, what are you getting? You are getting Na2CO3 dot 10H2O. This dot 10H2O, this is called as sodium carbonate decahydrate, okay, and this 10H2O is called as water of crystallization. Okay students, so what are you getting over here? Sodium bicarbonate, when you heat it, when it undergoes decomposition, you are getting anhydrous form of sodium carbonate. Okay, on addition of water, what you are getting is sodium carbonate decahydrate, which is the hydrous form of sodium carbonate. Okay, so the sodium carbonate obtained in this process is dry. So this dry or anhydrous variety of sodium carbonate, it is called as soda ash. Okay, the other name for anhydrous sodium carbonate is soda ash. Washing soda is obtained by, so this process what we have written over here, what are we doing? We are rehydrating. So here rehydration of anhydrous sodium carbonate is giving us sodium carbonate decahydrate, that is your washing soda. Okay, now what is the use of washing soda? We all know it is used in cleaning of clothes, okay. So you can see this detergent, Tide, Ariel, Patanjali herbal powders, okay, all these are nothing but your washing soda. It is also used in making detergent cake. Now what is detergent cake? It is not an edible cake. Detergent cake is like Rin, okay, Tide, Nirma, okay, these are detergent cakes and powders that you get to use directly in your washing machine. And it is used in removing the permanent hardness of water. We know when there are certain salts like of magnesium and calcium, when they are present in water, okay, it will not help in the formation of lather. So when you add washing soda to it, it will remove the permanent hardness of water, and also it is finding a wide application in glass and paper industry. Okay. So students, these are some of the uses of washing soda. So far we have learnt about different types of chemicals that are obtained from your common salt, sodium chloride, bleaching powder, okay, baking powder, baking soda, then we have learnt about washing soda. Okay. Now let us move on to the last part, okay, that is plaster of Paris. Okay. Plaster of Paris is called as calcium sulfate hemihydrate, okay, or you must have heard very common term POP. Now what exactly is POP? If anyone has met with an accident and has a fracture, to keep the bones in a perfect position, what the doctors do, they apply a plaster, and that plaster is made up of plaster of Paris. Okay. Even it finds very wide use in artificial ceilings. Okay. So the artificial ceilings are also made up of plaster of Paris. Now why it is made up of plaster of Paris? First of all, let us look how it is being prepared. Okay, so how is calcium sulfate hemihydrate obtained? Calcium sulfate is obtained from a chemical called as gypsum. So you see CaSO4.2H2O, that is calcium sulfate dihydrate, is called as gypsum. Now when you heat gypsum exactly at 373 Kelvin, temperature is very important, because if there is slight excess rise in temperature, then you are going to get something called as dead burnt plaster. Okay. So 373 Kelvin is the perfect temperature. So when you heat gypsum, it loses water molecule. Okay. When it loses water molecule, what are we having over here? Calcium sulfate dot half H2O. Now why dot half H2O? Because one unit of calcium sulfate, okay, 2 units of calcium sulfate is sharing 1 molecule of water. That means 1 unit of calcium sulfate gets half molecule of water. So we are getting calcium sulfate hemihydrate. Now remember student that this process of getting plaster of Paris, very important is the temperature. 373 Kelvin should be the exact temperature while you are heating gypsum. Okay. So on mixing plaster of Paris with water, gypsum is obtained. That means if you are having CaSO4.half H2O, and to that if you are adding water, it will regain its water molecule, and when it regains its water molecule, it again leads to the formation of gypsum. Now what are the properties of plaster of Paris? It is a white color powder, and it has remarkable property of setting into hard mass on wetting with water. Okay. Now that means on the moment you mix calcium sulfate hemihydrate with water, okay, it is, and if you leave it for some time, it is going to take the shape of whatever mold or anything you put it onto, and it is going to become very hard. That is why it finds a very wide use in hospitals for setting fractured bones. It is also used to make toys, decorative materials, sculptures, etc. And it is used in labs to seal apparatus. Now why in lab to seal apparatus? There are certain apparatus that require, if your experiment requires airtight conditions, then it will be used to seal the apparatus, and it is also used to make surface smooth before painting. So if you are painting a wall, okay, and you want it to be, you want to get a smooth finish, then POP will be used. Now remember one more thing, that plaster of Paris, it does, once it is being set hard, okay, it's not going to dissolve in water. So you know during, now soon we will be having Ganesh Chaturthi, which will be coming up, and students you know that always there is an advertisement which is being put up, do not buy Ganesh idols which are made up of POP, okay, because you know that the idol is not going to get dissolved and will start floating in the water bodies, thus polluting the water source. Okay. So though POP finds a very wide application, we also have to take care on how to use it and where exactly it is to be used. So over here you see it is used in carving sculptures, okay. It is being used to heal your fractured bones, okay. So these are some of the wide varieties of plaster of Paris. Now before we move on further, let us revise what we have done so far. Okay, we have learned 4 different types of chemicals, okay. Their common name washing soda, formula is sodium carbonate decahydrate, baking soda sodium hydrogen carbonate, bleaching powder calcium oxychloride, plaster of Paris calcium sulfate hemihydrate. You need to remember the common name of these salts, okay, of these compounds along with their chemical formula and their uses. It is being widely used, washing soda, we have seen it is being used in the manufacture of caustic soda, softening of hard water. Baking soda is used in antacid, it finds use in making baking powder. Bleaching powder, bleaching of clothes in textile industry, in paper industry, and plaster of Paris is used in setting of the fractured bones. So, these are the types of compounds that are prepared from your common salt, that is sodium chloride. Okay. So, students, so far in our lesson what we have learned? We have learned about chemical properties of acids, we have learned chemical properties of bases. Besides that, we have also learned a complete new type, that is salt, and how we are having different types of salt, acidic salt, basic salt and neutral salt. Okay. We have also learned how salt plays a very important role in our everyday life, and also how it is important to prepare various other chemicals. Hope you have all understood this lesson nicely, and we will see how exactly we are going to, after learning about acids, bases and salts, we not only need to know from the textual point of view, but we also need to know around us, okay, the different items that we are using, whether they are environment friendly or whether they are not, and what we need to do even to reduce its effect. Okay, thank you students.